Hey guys, hi, welcome back. So in the previous video, we have seen the harmonic conjugate functions, right? So in this video, we will discuss the Milne Thomson method. So you already know what is the Milne Thomson method. We will use the method to find the analytic function if either a u is given to us or v is given to us. That means if the real part or you can say the imaginary part is given, then we will find the entire function. Okay. So here one thing I would like to say, Milne Thomson method, it is the method by which we can find the function directly without finding the other conjugate function. That means if u is given to you, okay, then you don't have to find the imaginary part. Okay, you can directly find the function. So how we will find that, we will see. Okay, so for that we will consider the first case, that is the case one. That means when u, which is the real part, okay, real part is given. So for this we will be doing it in three steps. Okay, so the first step is what? For the first step we will differentiate u with respect to x and y. So first we will do del u del x equals to, and we will put it equals to phi 1 as a function of xy. And what you will do, you will differentiate u with respect to y also, and this you will take it to be phi to x comma y. So this is the first step. Second step, what you will do, you will replace x by z and y by 0. All right. So what you will write here, replace x by z and y by 0 in phi 1 x comma y and phi 2 x comma y. Okay. So here you will have to replace in this phi 1 and phi 2, x you will replace by z and y you will replace by 0. And the last step is what? You will have to find the function fz. And how you will find? You will write fz is equals to what? Integration of phi 1 z comma 0. Because after replacing, you will get this particular function, right? So you will have to integrate phi 1 z comma 0 minus I, okay, phi 2 z comma 0, all right, dz plus c. So this is how you can find the function fz. Remember here the sign is minus. Okay, this is phi 1, this is phi 2, phi 1 minus I phi 2 dz plus c. And you have to replace x by z and y by 0. So this is how you can find the analytic function when the real part is given. Clear? Similarly, you can take the case 2. In case 2, when v is given, when v, that is the imaginary part, is given. All right. For this also, the first step will be what? The first step will be, you will have to differentiate v with respect to x and y, right? But here what you will take? You will take this to be first psi 2 x comma y, and this one you will take psi 1 x comma y. Remember, when u is given, you are taking phi 1 phi 2, but here you will have to take psi 2 psi 1. All right. The second step will be same. You will have to replace x by z and y by 0, all right, in psi 1 x comma y and psi 2 x comma y. And the last step is what? You will have to find the function fz, and you will write it equals to what? Integration will be there. This time it is psi 1 z comma 0 plus I psi 2 z comma 0 dz plus c. Remember the sign here is what? Plus, but for you the sign was what? Minus. Rest everything is same. First step is same. You have to just remember this will be psi 2 then psi 1. Here we are taking phi. Replacing is same. This will also be also same, psi 1 and psi 2. Okay, the order is 1 and 2 only, but the sign will be plus here. Clear? So this is how you can find analytic function using the Milne Thomson method. Okay, now we will see two examples. So the first question is what? Find the analytic function whose imaginary part is vxy equals to this. So v is given to you. So you will have to find what? you will have to find the analytic function. So first what you will do, obviously we will differentiate v with respect to x, then we will differentiate with respect to y, right? Then we will replace, then we will find this function. So first let's do the differentiation with respect to x. So del v del x is equals to what? It is equals to psi to x comma y, right? So it will be equals to what? So when you will differentiate this entire term with respect to x, so this is u into with v, right? So this is u, e to the power x on differentiation will be e to the power x, and the bracket term will be x as it is. Okay, this I'm considering it to be a, or you can say b, this entire term. Okay, so x cos y minus y sin y. All right, this time I'm keeping e to the power x constant, and we will differentiate the term within the bracket. So with respect to x, you have to differentiate. So this will be what? Constant, right? So this will give you what? It will give you, this is x cos y. So cos y is also constant, and you will d dx of x is what? 1, right? So it will be equals to what? Psi to x comma y. Done. So finally, this is psi 2. Again, you will differentiate v with respect to y. So this will be equals to what? Psi 1 x comma y. So differentiate with respect to y. So e to the power x. This is constant, right? So it will be outside. Now you see the first term. Here what you will write? X cos y. With respect to y you have to do. So x is constant. Cos y on differentiation will give you minus sin y. All right? Minus. Here you see both the terms are having y, right? So first you will do what? Differentiating y, keeping sin y constant. So sin y, d dy of y is 1, right? Again you will write plus, this time keeping y constant. Sin y will give you what? Differentiation will give you cos y. Clear? So this is equals to what? Psi 1 x comma y. So finally what you will write here? This is e to the power x. All right? This is minus x sin y, right? Minus sin y minus y cos y. It is equals to sin y x comma y. Now next we will do what? This is the first step. Second step you see, replace x by z and y by 0. So when you will do so, you will get psi 2 z comma 0 equals to what? Psi 2 z comma 0. So this is psi 2. So if you will do this, you will get e to the power z, right? This will give you what? X can be written as z, cos y is 0, minus this entire term will become what? 0, right? And plus you will have e to the power what? Z cos 0. Done. So this will give you, this is z e to the power z, because cos 0 is what? 1. This term is what? 0. And this will give you what? Plus e to the power z. So similarly, what you will write? Psi 1 z comma 0 equals to, so if you see psi 1 z comma 0, sin y. Sin y is what? E to the power z you can keep as it is. So minus z. If you see sin 0 is what? 0. Again 0. All right. And y is 0, so 0. So if you see, this entire term will be equals to 0. Right. So finally I'm doing in this side. Here you will do the third step. Third step is what? You will write fz is equals to what? Integration. Right. You will write psi 1 z comma 0. And here you will have what? Plus I psi 2 z comma 0. And this entire function you will write dz plus c. So if you see psi 1, this entire term is 0. So you will have only what? Psi 2. So fz equals to what? Psi 2 is your z e to the power z plus e to the power z. Right? Integration of dz plus c. So if you see here, I will be outside. So I'm keeping I here. Integration. I'm taking e to the power z common. So this is giving me what? Z plus 1 dz plus c. All right. What we got? The function fz is equals to I is outside. integration e to the power z, z plus 1 dz plus c. Now we will integrate it. So integration of u v dx. This way we will do, right? So you know the formula, u integration of v dx minus integration d dx of u integration v dx dx. This formula we will be using. So I'm doing it directly here. Fz is equals to I. Okay, I'm considering this to be u, this I'm considering to be v. So I'm writing here z plus 1 integration of e to the power z dz. All right, minus integration of what? D dz of what? Z plus 1. All right, integration of e to the power z dz. And again, I will write here what? This curly bracket I'm putting, this is dz. All right, so now you see I, here z plus 1 is as it is. Integration of e to the power z is what? E to the power z minus. Okay, this will give you d dz of what? Z is 1, this is constant. So finally integration will be here. This will give you on integration what? E to the power z dz only. And if you see here again on integration, it will give you what? E to the power z. So I, okay, z e to the power z. Again you will have plus e to the power z. This is minus e to the power z. Okay, this integration will give you e to the power z will get cancelled. Here one plus c is there, okay, or the constant is there. So finally what you will get? I z e to the power z plus c. All right, so this is the function fz. Clear? The only thing you have to see that you have to do the differentiation very carefully and the integration also. Clear? Now we will see one more example. So here what it is said, if the real part of a complex analytic function fz is given, u equals to e to the power minus 2xy sine x square minus y square, then fz can be written as what? So real part is given u, okay? You have to say the function fz will be what? Okay, you will use the same method. This time u is given to you, okay? So what you will do? First you will differentiate u with respect to x, okay? And that is equals to what? Phi 1 x comma y. So when you will do so, this entire term with respect to x we will do. So this term I am keeping first what? Constant. So I am writing sine x square minus y square constant. This on differentiation will give me what? E to the power minus 2xy into with, you will have what? Minus 2y, right? Again you will write here what? Plus will be there. This time e to the power minus 2xy is constant. Sine x square minus y square will give you what? Cos x square minus y square into with, again on differentiation you will get what? 2x. So this is equals to what? Phi 1 x comma y. So you can write it as what? So I'm writing here minus 2y sine x square minus y square plus 2x cos x square minus y square. All right, and outside I'm writing minus 2xy, e to the power minus 2xy. I'm taking common. It is equals to phi 1 x comma y. All right, similarly you will differentiate u with respect to y. So that is equals to what? Phi 2 x comma y. So when you will do so, see this time you will have to differentiate with respect to y. So again I'm keeping first sine x square minus y square constant. This will be same, e to the power minus 2xy, but this time we will have what? Minus 2x, right? Again I'm writing plus e to the power minus 2xy is what? Constant. Again you will get what? Cos x square minus y square into with minus 2y, right? Because this time we are differentiating with respect to y, and it is equals to what? Phi 2 x comma y. So we will write it again, e to the power minus 2x, I'm taking common. Here you will get what? Minus 2x sine x square minus y square, right? And you will get again minus 2y cos x square minus y square. This is equals to phi 2 x comma y. Done. So this is what you are getting, phi 1 and phi 2. Let me write it again in the next page, phi 1 x comma y. It is equals to what? It is equals to, just check, let me check. It is equals to minus 2y, right? So it will be equals to minus 2y sine x square minus y square. All right. Again, here you will get what? Plus 2x cos x square minus y square e to the power minus 2xy common. Here you will have what? Phi 1 x comma y. All right. Similarly, you will write, sorry, this side I have written, so don't write here. Phi 2 x comma y, it is equals to what? It is equals to e to the power minus 2xy was common, right? Minus 2x sine x square minus y square minus 2y cos x square minus y square. All right. So this is what we got. Now we will write phi 1 z comma 0. All right. So this term will become, entire term will become 0. Here you will have what? You will have here, in this case, phi 1, he will give you what? 2z, right? Cos z square. Yes or no? Because y is 0. Similarly, phi 2 z comma 0 will give you what? This term e to the power minus 2xy will be 0 only, because this is 0, e to the power 0. So 0. So it will become what? 1. So this will also become 1 here, right? Here if you see, it will give you what? Minus 2z sine z square. This term will become 0 because y is there multiplied. Okay. So this is what you got. So you will write the function fz is equals to what? The formula was integration of phi 1 z comma 0 minus I phi 2 z comma 0, this entire integration dz plus c. So if you see here, you are having what? Integration, right? If you will take here common, because this is what? Minus 2z, right? So if you see here, this is 2z cos z square. Minus a minus will become plus I 2z sine z square. Okay. And this will give you dz plus c. Now if you see here, 2 I'm taking common, and within integration you will get what? Z cos z square plus I z. This z also, if you can take it outside. Okay, I'm removing z from here, so I'm writing sine z square dz plus c. I have taken 2z, 2 is constant, so it is out of integration. Z I'm writing here common, so you will get cos z square plus I sine z square dz. So now if you see here, what you know, e to the power I theta, it is equals to what? Cos theta plus I sine theta. This we have seen in the first lecture. So that only we will use here. We will write integration. 2 is constant. This is z. You can write it as e to the power I z square. All right. This is dz plus c. Clear? So this is how you can do. Now if you see, we will solve this integration. What is the integration here? You are getting fz is equals to 2 integration. You are getting e to the power I z square z dz plus c. All right. Now if you see here, in this case, if I take e to the power I z square is there, na? So this term we will solve. If I take z square is equals to t, so this will give me what? 2z dz, it is equals to what? Dt. So from here I can find the value of z dz equals to what? Dt by 2, right? So this we will substitute here. So this is 2. Clear? E to the power I z square. So e to the power I z square is what? T. Z dz can be written as what? Dt by 2 plus c. So if you see, this 2 will cancel this 2, and you will have integration of e to the power it dt plus c. So integration of exponential is obviously exponential, e to the power it. Here you will write one I also, right? Plus c. So this I, it will go to the numerator, then it will become minus I, right? E to the power I. T is equals to what? Z square plus equal right here what? C. So what is the answer here? The correct option is minus I e to the power I z square plus C. So it is what? E to the power minus I. Okay, it is e to the power minus I e to the power I z square plus C. Okay, the power is positive and here it is a minus sign. So the correct option is option B. All right. So that's all in this video. I hope it is not that tough. It's very easy. The only thing is that you have to do the integrations and the differentiations very carefully, and you will have to remember the function fz, okay? How the function fz can be written, both in case of u and v. All right. So you can solve some more problems. You can just go through the HK Das book. There you will get a lot of examples. You can solve 5 to 10 so that you don't have to remember the formulas again, okay? Once you will do the problems, so it will be in your memory. So that's all in this video. Thank you so much. Have a good day.